Welcome to Maths with Bob. This is the 3-minute series on growth and decay, and this is problem number 2. This is actually a decay problem, and you can see here the isotope is decreases by 15% in 30 years. In how many years will it halve its mass? Okay, so basically, obviously, you know, these are the rate of change of the mass is proportional to the mass. Therefore, dm dt equals km. The k is the constant, in this case a decay constant, will be negative, and we can assume a solution to this, m equals m naught e to the kt, which we'll have a look next. Okay, so let's have a quick look at how this does. Now, obviously the initial mass is m0, or m original, if you want to think of it like that, the original mass, or m as t is 0. After 30 years, the mass has decreased by 15%. Now that means it's basically 85% present, if you like, if you think of it like that. So m is equal to 0.85 m0 after 30 years. Okay, a 15% decrease. So let's have a quick look at how we go through this. Now, obviously we have to find the k, the constant. This is the first part of all these type of problems. We need to work out what is the k. Now, a couple of things. We are obviously assuming the solution m equals m naught e to the kt. We don't have to show that. We just assume that, and we just put in the values. Okay, 0.85 m0 when, you can see here, 30 years. So we divide by m0. Okay, divide this out by m0 and get 0.85 equals e to the 30k. And then we've got to get the k down. Obviously, we could just take the logs of both sides, bring the k down, the 30k down actually. You can see here ln e is 1, and then we just basically solve for the k. Okay, so we basically just divide everything by 30. Okay, and we keep it in exact form. You can see here, this is the exact form here. So we're going to keep the, if you like, the k constant in exact form. Okay, now, what do we do now? Well, we actually need to find the time for the mass to halve. Okay, the mass is actually then a half of the original mass, but we don't know what the time is. Okay, so we need to basically find this t here. So obviously we've got this, we don't know the t, but we do know the k. The k is this one here. Okay, so let's actually go through and see if a quick look at how we do this. Okay, so it's basically, you can see here, it's just a substitution, 0.5 m naught equals m naught e to the kt, divide by, again, we just divide by m0, we end up getting this 0.05 equals e to the kt, and you can see, remember the k was in fact this one up here. Okay, so we take the logs, you can see here both sides to the base e, obviously because this is an e here, we take to the base e, so we can get the log e equals 1, and then we just basically solve for the time. And you can see here the time is about nearly 128 years, or 127.95 years to 2 decimal places. That's basically the time for the mass to halve. And thank you for watching, and bye for now.